This is A21 Jun2009 for Module 4. This is question 1. State the principle of conservation of momentum. So there's two bits to this. You can see there's two marks. The total momentum before a collision is equal to the total momentum after the collision. And then the second bit is for saying provided no external forces act. Part B. A man is holding a rifle of mass 4.2 kilograms against his shoulder. The rifle is loaded with a bullet of mass 15 grams. When the rifle is fired, the bullet leaves the barrel of the rifle with a velocity of 250 ms to the -1. The man's shoulder is pushed backwards by the recoil of the gun. Calculate the magnitude of the momentum of the bullet as it leaves the gun. So you have to make sure always to change your masses into kilograms, and I've just drawn out the bullet there. It's got a mass of 0.015 kilograms and a velocity of 250 ms to the -1. So momentum is 0.015 times 250, and that gives you 3.75 kg ms to the -1. Explain why the gun recoils backwards. So if momentum is conserved, the total momentum before the collision is 0, and so must the total momentum be afterwards, and therefore the gun must have a negative velocity, in other words in the opposite direction to the bullet, so that momentum is conserved. And then the next question, calculate the magnitude of the velocity of the backward recoil of the rifle, and that is equal to 4.2 times v. 4.2 times v, that's the mass of the rifle multiplied by the velocity we're looking for, and that's equal to 3.75, and that was our momentum of the bullet that we calculated originally. And v comes out to be 0.89, and it is of course in ms to the -1. Part C. The bullet travels a horizontal distance and then hits and becomes embedded in a block of wood of mass 3 kilograms, which is freely suspended by a long string as shown in figure 1.1. And so you can see it hits the wood and it swings up to the side to a height h. Neglecting air resistance, calculate the magnitude of the initial velocity of the wooden block and the bullet after impact. So if I just put in there, the bullet has got a mass of 0.015 kilograms, and it's hitting the block of wood which has got a mass of 3 kilograms initially at rest. So the initial momentum then, mv, is 0.015 by 250, that's the momentum of the bullet, and that's going to be equal to the total mass, which is a 3 plus now the bullet embedded, which gives you it gives you 3.015, and it's times this common velocity, and the common velocity then comes out to be 1.24 ms to the -1. Part 2. Use your answer in C1 to calculate the kinetic energy of the block and the bullet immediately after the impact. So K is equal to half mv squared, and that's a half times m again is 3 plus 0.015 because it's the mass of the block and the bullet, multiplied by their new velocity, which we're taking our answer from up here, 1.24 squared. That gives you a total of 2.33 joules. Part 3, calculate the maximum height above the equilibrium position to which the block and kinetic and bullet rise after impact. And so if we have a wee quick look at the diagram again, you can see that the kinetic energy it has here is converted to gravitational potential energy here. And therefore half mv squared, which we've already calculated, 2.33, is equal to mgh of the block afterwards. So 2.33 is equal to, again, there's a combined mass of the block and the bullet, times 9.81 times height. And the height comes out to be 0.078 metres, or 7.8 centimetres. Explain why in a real situation the value of h as shown in figure 1.1 would be less than that calculated in C part 3, which is this here. And the reason is, of course, due to air resistance there'll be energy lost, and also there'll be energy lost due to the sound as the bullet hits the block. So you have energy lost due to sound and friction or heat. In the list below, mark with a tick the quantity or quantities which should be conserved in this impact. So the momentum is conserved, Kinetic energy isn't conserved because you lose some energy due to heat and sound, but the total energy of the whole system should be conserved. And there's actually 2 ticks there needed and only 1 mark awarded.